Hello students, this is Mr. Yao. In this lesson, we're going to continue to learn more about graphing quadratic functions. Since we have learned quadratic functions in 3 different forms, we're also going to learn to graph them with the 3 different forms. So first, graphing standard form, which again is f of x equals ax squared plus bx plus c. And just like when we learned about standard form before, the first thing we learned was to convert it into vertex form. And we actually use the completing square process to find it. So in this case, because vertex is a very important point, we typically, doesn't matter how we want to graph it, we always have to find the vertex. So we are going to use the h and k. So again, it's using h equals negative b over 2a, and then plug it into the function to find our k. That's how we find the vertex. But one point is for sure not enough. We'll also find the y-intercept. Because standard form y-intercept is when x equals 0. Well, when x equals 0, standard form is basically the c. So f0 is just the c on the end. So let's have a look at a few examples. Number 1, axis symmetry. Well, in the previous lesson, we have talked about the axis symmetry is basically x equals h, because the vertex is on the axis of symmetry. So we're going to find h first. Negative b over 2a. Our b is a 4. Our a is a 2. Well, is a 2, so multiply with a 2. That is negative 1. Which means our axis of symmetry is x equals negative 1. So let's draw the axis of symmetry first. Because it's not actually a part of the graph, so we're going to use dotted line to draw the axis of symmetry. Vertex, well, in order to find the vertex, now we need to find the k. K is going to be 2 times negative 1 squared plus 4 times negative 1 plus 3, which is 2 times 1 plus a negative 4, so it's a negative 2 plus 3, which is a 1. So my vertex is negative 1, 1. Negative 1, 1. Right here. Next, we need to decide if that is a maximum or minimum so that we can know the direction of our parabola, or which way it's going to open. Well, the a is a 2 is greater than 0, which means going to open up. So in this case, our vertex is a minimum. The y-intercept, again, y-intercept is when f is f of 0, when all the x's are 0. This is basically 0, c, which in this case, it's 0, 3. Lastly, we need to find an extra point, but let's actually put the points down that we have first. We have negative 1, 1. We have 0, 3. But with 0, 3, we actually have another point already. We also have this point to the left. Because parabola is symmetric, so as soon as we have a point on one side, we can also use we use reflection to find another point on the other side. Next, we need to find one extra point. Well, the y-intercept is 1 away, so let's find a 2 away. So let's find f of 2 times 1 squared plus 4 times 1 plus 3. 2 plus 4 is a 6, plus 3 it's a 9. So we have another point, 1, 9. Because as soon as we have 1, 9, we can also use reflection to find another point. 1, 9 is right here. We can reflect to the left. We'll also find this point. So now, lastly, we are going to connect them into a smooth curve. There you go. That's example 1. Now example 2. Same thing. Axis symmetry, in order to find that, we need the h. H is negative b over 2a, so it's negative of negative 2. 2a is a 2 times 1. So it's going to be negative of negative 2, which is a positive 2 over 2. So it's 1. Axis symmetry, x equals 1. Let's draw the axis symmetry at x equals 1. It's a dotted line. Next, in order to find the vertex, we need the k. So it's 1 squared minus 2 times 1. That is negative 1. H comma k is 1, negative 1. That's our vertex. And our a in this case is a 1 in the front. is greater than 0, so it opens up, which means the point, the vertex we have, is a minimum. Y-intercept, well, in this case, our y-intercept is a c on the end, which doesn't exist, so it's just a 0. Y-intercept is 0, 0. As soon as we have 0, 0, that means we have a point to the left side of the axis symmetry. We can use reflection and a third point on the right side. Now we need one extra point. Both points are 1 away from the vertex. Now we can try to do 2 away. So let's say you can either do f of -1 or f of 3. 3 squared minus 2 times 3. That is also a 3. So the point is 3, 3. Which also means we have another point on the left, -1, 3. There you go. So that's our parabola. Third one, axis of symmetry. H is negative b over 2a, so it's negative 18 over 2 times 3, so it's a negative 6 over, negative 18 over 6. So negative 3. There we go. That's our axis symmetry. X equals negative 3. In order to find the vertex, we need our k. 3 times negative 3 squared plus 18 times negative 3 minus 2. 3 times 9 is 27. Then minus a 54, it's negative 27. Minus 2 is a negative 29. Well, that point is actually quite far down below. Negative 3, negative 29. And our A is a 3, which is greater than 0. So our vertex is minimum again. Y-intercept is just at our C, which is 0, negative 2. Which means we can also find a point to the left. This is 3 away from the axis symmetry. So we can also find by reflection. We're going to have another point. Well, we can either do -1 or -2, either way. So let's say we're going to do f of -1. That is 3 times -1 squared plus 18 times -1 minus 2. That is going to be a positive 3 minus 18, then minus 2. So positive 3 minus 20, which is a negative 17, which is also a point quite far down. Well, unfortunately, I didn't give enough of a graph. But during a test, we're not going to have a question like this. So at least this way you can see you're going to have a -1 at -17, quite low, and your vertex is even lower, which is at -3, -29. So it's good practice to find some points. And after that, well, what is the benefit of actually using standard form to graph? Well, the vertex is not very hard to find, even though it takes a bit of work. We have practiced with h equals negative e over 2a for a bit time. But the benefit is we can easily find the y-intercept. We can just replace the x with 0, or in other words, we're going to use the c on the end, so the y-intercept is directly 0, c. That's the benefit of using standard form. Moving on, graph in intercept form. For intercept form, we have learned it's f of x equals a times x minus p times x minus q. And the p0 and q0 are the x-intercepts. So as soon as we are in intercept form, you just need to remember we're going to need to use the opposite number of what's inside the parentheses to actually get us the x-intercept. Then you already have 2 points. X-intercepts are also called zeros, roots, or solutions. That's a sentence we have repeated for quite a few times. Let's have a look at some examples. f of x equals x plus 1 times x plus 5. Well, intercept would be 0, -1. Sorry, not 0, -1. It's -1, 0, and -5, 0, because we always have to use the opposite number of what's inside the parentheses. -1, 0, and -5, 0. But just having these 2 points is not quite enough. We can also have a vertex, because we have learned how to find the vertex. In this case, it's p plus q, so -1 plus -5 over 2. That is a -3. So again, it's p plus q over 2. Then we can plug it in to find a k. -3 plus 1 times -3 plus 5. It's a -2 times 2, so it's -4. -3 negative 4. Right here. Well, the two x-intercepts are already symmetric, already reflection of each other across the axis symmetry, which is actually on the vertex. So we can find one extra point. We can either do f of negative 2 or f of negative 4. Negative 2 plus 1 is a negative 1. Negative 2 plus 5, that is a 3. So it's a negative 3. We have a negative 2, negative 3 as an extra point. Reflection to the other side, now we have the fifth point. And then we have our fulcrum. That is our parabola from intercept form. More examples. Example 5. Intercepts, that's going to give us a positive q. This one is going to give us a negative q. So I have a 2, 0 and a negative 2, 0. H is p plus q, so it's 2 plus negative 2 over q. That's a 0. K is negative 2 times 0 minus 2 times 0 plus 2. So we have a negative 2 times a negative 2 times a 2, which is a positive 8. And from this, we can also know, well, our A is, well, let me write down the HK first. It's 0, 8. And let's still practice real quick about the minimum and maximum. Well, in this case, our A is right here. A is negative 2, which is less than 0. So now our graph is facing down. So that means our vertex is actually a maximum. The points, the x-intercepts are also 2 away from the vertex. So we can find one extra point in between them. You can either do f1 or f of negatives. Let's say we're going to do f1. That's negative 2 times 1 minus 2 times 1 plus 2. Negative 2 times a negative 1 is a 2 times 3 is 6. So we got a point 1, 6. Reflected to the left side, we also have a negative 1, 6. And that is our parabola. Moving on, example 6. This question says factor, then graph. Well, let's factor. We can actually take out a negative 3, then we are left with a 2x squared minus 7x minus 4. You can do your big X or factor by grouping, either way. You should get negative 3 times 2x minus, let me think, minus 4 times x plus 1. Oh, oops, that's not going to work. It's going to be a plus 1 and minus 4, should we? But we're not fully done. That is not the intercept form. We're going to change into an intercept form, negative 6. Divide that parenthesis by 2, so it's x plus 1 half, and then x minus 4. So the two intercepts, we have negative 1 half, comma 0, and a 4, comma 0. Negative 1 half, comma 0, and a 4, comma 0. Axis of symmetry, well, that's going to be our h, which is p plus q over 2, which is negative 1 half plus 4 over 2. That is 7 halves over 2, 7 fourths. X equals 7 fourths. We're going to need to do a little bit estimation. 7 fourths is very close to 2, but is a quarter into that. So there you go. That is our axis of symmetry. Now we're going to calculate our k. Negative 6 times 7 fourths plus 1 half times 7 fourths minus 4. That is a negative 6 times a 9 over 4 times a negative 9 over 4, which is, well, that's going to be a quite big number. So 16 on the bottom is 81 on the top, but it's going to multiply with a 6, so it's actually going to be an 8 on the bottom. And negative times a negative is a positive, and it's going to be a 243 over 8. We can do a bit estimation. It's going to be 30 point something. which unfortunately is another one that I didn't provide a big enough graph for it. So at least we know the vertex is 7, 4, comma 243 over 8. And when we try to find an extra point, well, we can always use the easier point. Let's say we can use this point right here. The only issue is when you try to reflect it, it's going to be a bit hard. We can totally use f of 3. Or if you want, you actually use like a 1/2 here, since that is going to be 3/4 away. And on this side is also going to be a 1/2. Well, which means it's easier to actually define f of 1. Let's do f of 1. -6 times 3/2 times -3. So that is going to be a positive 27. So the point we can have is a 1, 27. So unfortunately, we can't put it on the graph, but it's actually a good habit to practice finding some of these hard numbers, because when we have like a graphic calculator, it's going to be easier to calculate these things. So now let's talk about the benefit of using the intercept form to graph. Of course, you can find the zeros or the intercepts very easily. You set it equal to 0, and you're going to get a p comma 0 and q comma 0. With that, you will soon have the vertex as well, because the h is p plus q over 2. So that's the two different methods to graph in this lesson. Thank you.